This is a demonstration showing the MOQT implementation in libquicr, and we're going to show two different examples here, and I'm going to do them as quick as possible. So the first one's going to be the date program. So what I'm going to do is I'm going to run the publisher for the date program, which, by the way, I already have the relay running in a different screen, so you don't see the relay, but this is going to show the clients. What I'm going to have in the gray box below is I'm going to have the publisher, and I'm going to start the publisher up to publish the date. So I have specified it with the settings by basically saying to run the client and publisher namespace clock. The name for the track is going to be second. We could use anything we want here, but I'm just going to use that. And I'm going to say that run this as a clock. So this is going to run as a clock. And as you can see here, it's not actually doing anything right now other than it published the track, but that's basically it. I'm going to start the clients up, and when I start the clients, I'm going to run them in the same way as the publisher, but what I'm going to do here is I'm going to run it by running the namespace clock and the same track name second. So when this connects, the first thing that happens is the subscription takes place, and when that happens, the publisher gets notified. And when the publisher gets notified, it starts publishing. And we can see that happens immediately. So now we have the clock. So that's great. What we're going to do is we're going to run a second one for another subscriber. And what we're going to do is start this client up using the same thing. So it's going to be the clock. It says using second, and it's going to get the same information. So we have multi-subscribers to the single producer. So that's really great. Now that's our clock example, which is probably the most basic example of this working, and that is obviously single publisher going to any number of subscribers. But let's look at a chat program instead. So we'll go ahead and run a chat program. And in the chat program example, what I'm going to do is I'm going to run the publisher. I'm going to actually run all of these screens that you see here exactly the same. I'm going to run it where they subscribe to namespace test, publish to the track name of chat, and they're going to do the same thing for publishing and subscribe. So it's exactly the same. So subscribe and the publishing are the same. So test, test, chat, chat. And we're going to do the same one. Now, if I run this, it's going to immediately say that you're ready to send data. And that's because I subscribe to myself. So if I type in, hi, this is me in the top window, it will print out that this is the message being sent, and it will say that it was received. We basically echoed this back through the relay. But let's go ahead and run this with multi-publishers. So I'm going to send this with multiple clients going to the exact same namespace. So I'm going to do the exact same command and run this more than once. So I'm going to subscribe to namespace test and chat, and I'm going to publish to namespace chat. So this one is available to do that. And I'm going to do the same thing down here. So 3 windows doing the exact same thing. Now I'm going to clear these windows because I keep it clean looking. So I'm going to say hi from the top window. Now notice I do see my own message coming back to me. We can selectively turn that off. We can selectively do what would be considered split horizon in terms of routing terms and whatnot, but we can basically prevent the reflection back if that's the desired result. But right now it does print it back to ourselves, so that's okay. So it says we received our own message that we sent, but these other clients got a copy of it. Hi from the top window, hi from the top window. I can say hi from the middle window, and we can see that this guy sees hi from the middle window, and this one sees hi from the middle window. And of course we see ourselves hi from the middle window because it's echoing itself back to itself. And I can say hi from the bottom window. Oops, misspelled the window. Hi from the bottom window. And if I can type it, from the bottom window. And we can see that these messages are in fact, even with the misspellings, they are in fact making it to all of the windows. So everything is synchronized. Sync A, sync B, think C. All of them see the same thing. They're all working against the same chat room. I guess you can kind of consider this like a chat room. If you were to go to the same room and you just want to broadcast your messages to the same room, this is an example showing that. And this is all using MOQT draft-04 implementation, full compliance. And there is some documentation that goes over the implementation of this and how we're doing it with multi-publisher and multi-subscriber, and supporting any connection type as coming in as publisher first or subscriber first, or the other way around. But whenever you join in, I'll just kind of show this here. If I say hello from the bottom, the top one is still working because I'm still connected. Obviously the middle one was disconnected. I'm going to go ahead and reconnect it again and say, are you there? And now it shows, are you there? Of course, the top one gets it as well. So they all seamlessly interwork, maintaining the state of any publishers or subscribers connecting at any time when they connect. That's the demo.